then we can start with your presentation.
Yeah, Manish, you have joined?
Yeah, he's chatting.
4 o'clock is also fine. Then in that case, I can start what I was to present yesterday, right now.
Okay. Okay.
Shall I?
Okay.
Okay.
Okay, then we can. Okay, sir. I just write him.
So that we don't disturb the second engineer.
We can take the RVS assessment form first, no?
Okay. Let me start with mine.
Okay. So let us start the program. I welcome all the panelists, experts and participants on the third and the final day of the 3 days long training program on rapid visual screening of built up facilities. My heartiest welcome to the today's resource persons, Professor Chandan Ghosh, Mr. Manish Kumar Bharti, CEO from Corex Construction Solutions, and architect Nitin Verma, co-founder and managing partner of ACI Noida. So yesterday we had discussed about the non-structural criteria and vulnerability mapping of the buildings by Dr. Amir Ali Khan, who is faculty here with us in NIDM and who had shared his experience from the field, gave example from Delhi as a case study and so on. Another presentation was done by on deficiency in caudal provisions and performances objectives of buildings during earthquake by engineer Amardeep Garg, managing director, creative design consultants and engineering private limited. So today is the third day of the program and we will focus on the constraints and certification based on RVS scores in context of making DM plans. Also retrofitting of building case studies would be covered by Mr. Nitin Verma, and a discussion would be taken up on RVS format by Professor Ghosh, and this will be an interactive session. Since Mr. Manish has already requested for shifting his presentation at 4 p.m. So now we will start with the first presentation by Professor Ghosh, and that will be on interactive discussion, and wherein we will discuss about the format. So thank you very much. Professor Ghosh, over to you.
So let me share my things.
Okay, yes.
Okay. Okay, is it visible?
Yes, sir.
Okay. So this is something that I'm going to show about the case study of 10,000 buildings in Delhi, which was taken up after following the Lalita Park building collapse. Of course, the study taken up in November onward, not November. It is building collapse happened in November 2010. And then we took up it in 11 and submitted our report in November 2011, this survey report. And the report was submitted online because the format that which we are going to discuss quickly today, even after that in the last session, also last part of today's session, is about the kind of software that developed at that time in PHP programming at NIDM. These are some of the photographs that taken where the building that which you can see, which was collapsed over here, all in a sudden. But at that time it was raining heavily, and 2010 was the year where Delhi organized this Commonwealth Games, and at that time. In fact, there was a heavy rainfall in Delhi, it was a record rainfall, and which has inundated many of the areas in the east part of the Delhi. And that resulted this building basement inundated for even a month, and which remained like that because the basement was such that it was just not possible to pump out the water, because the basements were not made into account that someday it is going to be inundated by flood water or extra rainwater that coming from the nearby Yamuna river, which is hardly Yamuna, that where Delhi is there. It is hardly, say, a few 100 meters away from the place that where it is. So in fact, here I'm showing that only a screenshot of the things that we had developed at that time when no such program or RVS, rather WhatsApp and other things, just they were taking 2010-11, you can see at that time that not much of computer literacy for the user level or social media level was available. So making a format and transforming those format into each cell as a information. So each one having more than 300 aspects of the building, which I am going to show, and then putting them in each cell, which I go in little bit of detail. In fact, follow-up of this program after today will be taken up that nationwide survey of the buildings, like population registry that we develop every 10 years. So it will be taken as a building along with the photographs and using our, facility for mobile app where this building photos will be taken, and then audio, video, text, everything will be recorded and they will be submitted by each of the surveyor. So the effort will be that to train a number of students, especially in their third year summer training, or those who have graduated engineers that who will be trained these things maybe in 3 to 5 days of face-to-face program, and then get familiarity with how this survey are to be done physically, like we have been doing this survey physically, each building, and then deploying them, employing them with certain amount that which is to be taken up, and then deploying them through this mobile app or whatever, online, offline, and then a robust server will take care of all this database which will be taken up. So that is the aim of this program after this is over today. So I would say that this was at that time developed, that were username, member logins and everything which you are familiar with. And this is that photograph that which all the 5-story over here, it is just like here as a pancake that on November 15th, which is Tuesday around 8:15 AM, it all in a sudden, not all in a sudden, but it gave a lot of indications, but people around, it is a private building. So they were not, and the basement was having a lot of water inside. So it gave some indication, but it was not noted in a manner that someday it will kill or it will fell like this, and 73 people died and 65 got injured. This was the building photo that while doing this investigation, before we could collect from some sources that this was the building before the collapse. This we could collect at that time from some sources. And then after collapse, this is the condition, the other side that you can see. Now let us see that taking us that we have been doing some kind of exercise, but very few such studies meticulously done in our context here. So that is why, in order to take the inspiration from some of the well-known case studies that like Kobe earthquake, post-Kobe earthquake, building damage data in this city only, that which is being presented in one of the paper by K. Hori et al., and which was survey was done following the earthquake, and then it is published in 13th World Conference on Earthquake, Canada. The paper is there online. You can see, just I have taken from there that what kind of meticulous survey on, and what are the measured damage ratio In 1996 itself, this survey was done following the earthquake in 1995. And this is the earthquake, epicenter. And this is the area that where they are dotted. But this paper shows that study in the Nishinomiya city that they have tried to check that each and every word over here and then publish them in the form of report. Just not going into the details, the paper gives a very nice details about the survey, the damage survey that they have done following the earthquake, is that just strikingly major damage without survival space is almost 85%. Major damage with survival space is hardly 5-6%. Minor damage and moderate damage like that. So this is the kind of concept that major, minor, or moderate the damage. This word, these are qualitatively they are being said, but there are certain parameters by which we say major, minor. So which we will go into a little bit of that details. And this needs not only software. Software only can make the repository of information which will be collected, collated through the site visit. So for our civil engineer, electrical engineer, mechanical engineering graduates, or even those who are in their third year summer program will be there 2 months of training, 2 months of mandatory summer training that you are having. In that period, we see that you are engaged through CIDC, AICT, and other university institute program with the MOU, along with the ministry, that by that time that the summer vacation comes, that our software will be ready so that we can train you, or you get this facility for visiting the site along with the experts, along with us and many others that who are getting familiar with these things or already having a lot of experience, that we visit the site, and then along with that, in all our mobile, offline or online, that space will be created, and then you will be interacting and taking the photographs and check that which are the vulnerability, which I'll show some of those details. If time is not possible, maybe later on, of course. And then put out such kind of map in across the country, taking some of the facilities as a model study, pilot study, and then at least have such kind of information available to the decision maker, especially even private, public, all kinds of buildings, including bridges and other lifeline structures and everything. So when a building of say 3-story or 4-story we want to make, how much time it will require? For that we need some kind of tools, which of course we are not taking up here itself, because it is a only awareness program. In order to make 1, 2, 3, 4-story building, to survey each of these things, in fact, it will take several days or months. Even many of the things will not be visible by only seeing it. So we need to have an entire geometry of these things, entire geometry of the building. So only simply going through taking photographs is the first step. We have discussed on the first day, level 1, level 2, level 3, and detail. Then we have to go into the detail, level 3, depending on that, what is the necessity and importance of that. But we will take such kind of pilot study of a building. And if we do level 1, level 2, level 3, for this building, which is, say, for example, it may take more than 15 days for one building. So think of our population and number of building units across the country, and also taking care that 60% of our country's area, they are in the earthquake prone area. So if we only go into earthquake prone area, or if we go into vulnerable buildings in the coastal areas, you will see that it will take years and together, maybe several decades it will take. So at the same time, now, since we need a geometry of the entire building, inside, outside, So you think that we'll take theodolite or we'll take measurements, everything by scale or by whatever survey instrument that we did in our college days? No. We have to keep those conventional system, but at the same time, we have to keep certain kind of, like these days, LiDAR camera are conveniently being used from outside photograph, inside photograph, matching them, making as-built drawing for the designer or for the contractor or for the companies or agencies. You may see many of the application of this LiDAR camera based survey, like monuments, like many of Ajanta Ellora or and like Qutub Minar. We cannot measure by scale or other things. So we have to go by those kind of laser camera that which can capture the photograph even from a kilometer distance with minute details of even a millimeter or centimeter, whatever it is, and inside and outside, and software is there to make a as-built drawing so that we can analyze them or we can relate them. At least we should know their dimension, because for engineers, drawing is the language of engineers, which we have learned at that time in our college days. But at the same time, dimension, XYZ dimension is very much necessity, and with as accurately as possible. If you say that as accurately means how much, when you do the software analysis or say design, we need to know each and everything, even a point-to-point details in millimeter or even sub-millimeter details. So in that case, getting those details have become very much comfortably easier these days with the use of LiDAR camera or the camera that which can measure, or laser camera, laser along with the camera that where we can get a feeling of the 3D as well as walk through and also the color sensations and everything, so that each and every dimension is known and mapped and measured, so that it helps us in taking estimates about the repairing or other things which will help later on. So now there are many steps are there. Of course, it is taken from somewhere else about India, and these are the various steps like rapid visual screening survey. Here you say survey word is also there, screening survey, and detailed vulnerability and case-specific vulnerability assessment, which we have discussed. And then type of buildings, masonry, RCC, steel, wooden, mixed, and then industry, and many such types are there. So you think of, while we are going to make the software, it will have the provision for classifying the building, which will come. And then what are the vulnerability factors for building typology? Its location, whether it is here, or hill area, slope area, all those soil conditions, seismic zoning, local and collateral hazards, and then construction material being used, and the ages, then building features and profile, whether it is cantilever, soft story, steel, whether it is having a mixed or whether it is having a, retrofitting has been done before or not. So you can see at least, say, what we did in 2011, it was having more than 325 aspects, which I'll show. But if we go into finer details, there may be more than 2,000 parameters that which we have to be identified while going for step 1 means level 1, level 2, level 3. So in that case, so the server or the software will have the space for keeping all this data. So you think of for each building, if we are keeping 2,000 plus parameters, and for each of them, if we are putting them, because we have to make them a searchable file, which I'm going to present again. I don't know, time will not permit, which we did in 2011 while surveying 10,000 buildings in Delhi. So for that, it is a searchable thing. Say how many buildings are there having steel? Just put a keyword there, steel building, it will give you where they are located, what are their photographs, what are the expert decisions given. All these things that we have made available at that time. So now you see, these are again some of the criteria done here itself by some of the organizations that damageable, damage grade. These are all recognized in the code, building code in 1993. Damage grade 2, damage grade 3, damage grade 4, damage grade 5. So these are all nothing but a guidance compared to the damage grade shown here in the sketch and the kind of damages that which are being shown over here on the on-site. So our aim is to get all of you get familiar with seeing the idealistic sketches or damage being picturized over here and getting familiarity with the matching with that in the field. So you can think of that how much of not the knowledge, I would say, but an understanding the motive behind going for such kind of damage classification. So there are in Japan itself in the same paper, you see they have got damage grade D0, 1, 2, 3, 4, 5, 6, 7 such grades that they have made. See, they have got a similar kind of classification. Here there is no damage pattern of 2-story wooden building, which they have taken as an example at that time. So we have taken some inspiration from such kind of discretization of the building damage category that done by various agencies across the world as well as in the country. So these are the guidelines, the building damage pattern chart for wooden buildings only. If it is RCC building, if it is steel building, or if it is like prefabricated building, mud type of building. I think day before yesterday I was mentioning in one of the projects taken up by NDMA more than a decade back, there are in India the different about 33 types of building type, 33 types of building have been identified. So you can say Assam type house, Dhachi Diwari house, that is also one of the type. So we say the mud house. So there are mixed construction, there are prefabricated construction. So all these things have been categorized there. So while going for this survey, we have to put those typology already defined and available into our say server, or so that wherever the survey will be done, irrespective of the places or geology, that at least building types we have to predefine in the software so that you can match, you can select that which is the type that the building that you are surveying, so that we get those authenticated information from the field. And then while before making the report or before making the proper categorization, like they have done over here, like here, something like this. So you see that it is a huge exercise that we have to take care from now onward, while going towards this discretization of the building damage or type. Not that only damage, it is one damage error, but also building type which is undamaged or which is currently existing. So which are currently existing, and when we are mapping the their current situation, then there are some other criteria which are to be populated into the software. So according to grade 1, grade 2, grade 3, and then so RCC building, then masonry building, like in our survey, we have identified 20 types of buildings. For each of them, such kind of category will come. So you can think of that amount of database that we have to handle, and they are to be related and then characterized, and then category of the building and vulnerability based on the factors like say hazard, whether it is earthquake, whether it is earthquake and landslide, whether it is earthquake and flood. So those category will come thereafter when we'll be able to match them. So and relate them based on the type of building and then type of the hazards, whether it is single, double, mixed, everything. So it is a huge exercise to be made. And I would say that is a much more complex than that we have been thinking of so far. So there are 5 types of destruction, very heavy structural damage destruction, which are given pictorially, they are being also shown. So there are certain way to scoring them, because whenever we are making building damage as a category, you see grade 1, grade 2, grade 3 doesn't make any sense, except that by seeing the images that we can make a sense, but that needs an experience. But what we have to convert them into number or some scores or some kind of standards or compare and probability, and so lot of approach have been made. So I will not go into those details, but basic structural hazard scores, score modifiers, final scores are all measures of seismic damage potential that building under evaluation. So it is a log 10 of collapse given to maximum considered earthquake. So these are some kind of say basics that which are involved, which we have to incorporate before making the software out for survey for the trained say engineers or even students in the next year. So just only giving that what scores means based on the consideration taken, calculated probabilities of collapse versus final score. So you see when it is score is as high as 4, so probability of collapse is very low, 1%. And when it is 0, so it is at maximum considered earthquake. These all structural engineers, they know. And so these are some of the things that will be taken up, not available, or it is not under the scope of IS 1893. And based on that, you know, basic score, then whether it is then soil class, whether it's a soil class also will be taken up. So when soil class, according to NEHRP USA, International Building Code, of course, they have made that hard rock, very dense soil, steep soil profile, soft soil profile, and something that which is even much more weaker or which is not engineering soil. For that, even when depending on the type of soil, or when it is hard rock, then if earthquake occurs in a hard rock, their response will be something different than if same earthquake affecting the subsoil, having the building that we are considering. So these things, of course, as I said, that we will come up, but these are the methodology, FEMA methodology, which is also revised recently, or rather 2013-14, based on these things, which is a different area. And then type of building, you see what they have done and what I have said we have done. They have made about 19 types of buildings. And here you see concrete means C1, C2, C3. And then tilt-up building, we are also having many PC1, PC2, precast building. Then you see light wood frame residential building. So these are all classification defined in the FEMA code. Initially came up in 1988, then it was revised. Then again, further it has revised. So it is available online. You can see these details. So finally, we come to the RVS score and then rapid visual screening score according to the FEMA. And then we come into that. Okay, let us go into, this is one in seismic zone 4-5, which is being adapted in in our code from FEMA 154. And also, this is being adapted to our code way back in 1993, and then some of the rapid visual, these formats are available in the code, and this gives maybe we can make some kind of score based on the procedure that which has been defined. So while going for the real building check, which we are aiming at for this was done way back. Now, along with the software that in a mobile or in our laptop or desktop mode, we would see that while seeing the buildings, like here it is a physically it is being done. So when this scoring as per this definition, after visiting the site, we'll be putting them in this manner, then we'll get certain information which is valuable, which we want to make it available in the website, and also for the decision maker, or whether it is in all the line ministry or departments in the country, for taking necessary steps for further while based on this classification. See, all those classifications are mentioned over here. So anyway, there are many other things. Let me go directly to the quickly because time is. Oh, all right. Okay.
So time,
just
yeah.
2 minutes I can take.
Yes, sir. I was speaking to Nitin sir if he can. I mean, if he's I think already here, and if he could wait for 5-10 minutes, then you can complete your presentation.
Okay. No, he has joined.
Yeah, it seems his name is appearing.
Okay. His name, then okay, because this will take maybe after that I'll take it up later on.
Okay, then you
because
can
this
take
is what my topic was, that how we did the survey, just only 1 minute, and how many things, how many buildings that we have done, which are the date. These are in 2011, 30th to 19th May, almost all the 64 wards in Northeast Delhi. More than several MCD engineers were involved. And finally, we got this data, mostly 79% residential, commercial, mixed use, storage, shopping mall. There are about 20 types, even police station, of course, we didn't go. Petrol pump also didn't, but we kept this classification. Schools and religious places and all these, and buildings surveyed by MCD, 10,334, and which we have shown that we have done a special survey where we have given a lot of time, more than 300 buildings. Authentically, resident, because here mostly we have done a residential building, but whereas when we have taken a smaller sample, then we have gone into all building types: educational, fire station, hospital, and then petrol pump, religious building, 2% out of 300, say 6. Then so all these things that we have done under construction building also we have checked, water tank and school 4%, like that we have done at that time. So, and these are the spots. This is the Northeast Delhi. These are the spots that where 300 buildings have been surveyed. So these are all being shown over there on the, from the Google Earth at that time, that available in 2011. We just, so we have concentrated most of our building here itself, but we have taken from all these spots that which are shown in the green to represent all types of things. And in fact, these are the, in the Google Earth itself, at that time satellite data were not available. This is the ITO, and this is Lakshminagar here. A building collapse occurred over here. We have done maximum here at this place. And these are all being done without any expenditure by some of the students that we have hired. More than 30 students we have hired for about 6 months on a daily basis. And then they have gone to all these places. And these are the area, that open area, park area, building area, in a particular, using the Google Earth, only just using some kind of guesstimate or some kind of, you know, such kind of authentically just drawing this and showing them which are the area or which, and identifying them, because we know. So while showing that building area in East Delhi, how much is the building area? Because here we have said that what is the building area, red colored. So in fact, rest of the things are building area here. So we have checked that what is the area, you can see building area in meter square, and also showing them that what are the road area, how much is the road area. So all these things we try to discretize. Anyway, land uses in East Delhi also plotted, and then in one of the ward area, that how many are the building area, and then what are the other area in Ashok Nagar itself, building type, brick, masonry, cement, all these 20 types, but here few types only we have done. And then building area wise also, authorized, regularized, unauthorized, resettlement colony based on MCD. That categorization, age of constructions also have been categorized. This have been possible because we have made the software, and then we could search them from that software, which I have shown in the first page of this presentation. So we could find out through a query searching, and then use all this kind of categorization, plotting them, all are available even now also in a spreadsheet that we can put them in whatever format that we want. Most of the buildings are internal. On the both sides that there are other building properties are there. Corner area and other things. Whatever keyword, because as I said, 325 cells were made. So 325 into 10,334. So many cells are there, cells of information are there. So a query search can be made any 1, 2 or combination that which gives us this kind of data. Then basement. No basement, 89%. And then again, all these things I'm just showing quickly. And then we have to make all this database, residential and everything. And this is the format at that time you have taken. You see that building type and all these things later on we have made into the software as a query. And then this is that records, 10,448 records, which are showing that ward area, and these are the buildings. And along with that, 6 pages of the format, which is also made available over here. In fact, we have submitted entire thing, 60,000 pages of information in a software form and also in a printed form with more than 1 mirror of printed things, because Port wants everything in print. So that way that we could submit everything in November 2011. So all the search and queries, everything is there. South zone of Shahadra, north zone of Shahadra. This you can locate me. I'm there taking cognizance of all this, and we have visited and several engineers cooperated, and then 30 plus students that we have involved in our work, including graduate students also. Okay. Let me end over here. There are many other things that we have to do, as I have mentioned, LiDAR and walkthrough survey. Through that only we can make the things more easier and more smarter, and lots of information that we can make it available for the decision maker. Thank you. We'll discuss maybe at the end.
Yeah, yes, sir.
Okay.
Okay.
Sorry, Nitinji, I have taken your time.
Thank you very much, sir, for a very informative presentation and also unique in nature. I think we need to take up such surveys and studies in different part of Delhi as well as in other cities also. So because you have already said that we will discuss this presentation after other 2 presentations, so we straightforward move to the next presentation by Mr. Nitin Verma, who is co-founder and managing director of ACNI. On retrofitting of buildings, the case studies. Sir, Professor Ghosh, would you like to introduce him more?
Yeah, he doesn't need any more introduction, because Nitinji is the very practical as well as pragmatic as well as practical architect come engineer. He knows more engineering, site engineering than.
Sir, you may need to unmute him also.
Okay.
Yeah.
He has been doing a lot of projects across the country and making retrofitting really feasible, achievable, and acceptable to the community. And many government and non-government infrastructure he has taken. So most probably he will highlight today one of the school building that he has taken up, which I visited recently in Delhi, central Delhi, which is going to do that. What is the real retrofitting that we think of beyond theory, but with practice, and the kind of analysis that as a backup that, and also having a control on the retrofitted structure with some kind of seismic controller, say dampers or some kind of device that they are going to install very soon. So it will be a very practical example. I would see that Nitinji is going to present before the participants today.
Yeah, I request Mr. Nitin to just switch on the camera so that we can find him out, and then we can unmute him.
Oh, yeah. Please,
yeah,
welcome.
Okay. Sir, you may need to unmute him. Professor Ghosh, you have to unmute.
Yeah.
Okay.
So can you hear me?
Yeah.
Yes, sir.
Okay.
Okay.
Good.
Thank you, sir. Thanks a lot for the kind words. I mean, we have been your protege. We have learned a lot from you. Obviously, you have been a guiding force altogether. Yes, we have worked in the field slightly more. We have faced all the things that we probably are trying to show to your group at this moment. I've been through most of it. Probably, I mean, beginning my career under your guidance in 2000 from the super cyclone in Odisha, and then Indian Ocean tsunami in 2004, then 2011 Sikkim earthquake directly under your supervision, 2015 Nepal earthquake. Yes, I understand these disasters and these things, and I've been a part of the first response team. So what I want to show today is some more general information. I mean, yes, I will touch upon the modern school, which is the biggest school in Delhi, which has now been seismically retrofitted. And ACI has been the designing and the execution team behind that. So if ma'am, you can allow me to share my presentation on the portal.
Yeah,
If
you can share from your end that share green screen is there.
Yes,
the below
screen.
Yeah.
Yes, sir. So this is what is it visible? Yeah. Okay. So I'll just give a brief background to the audience about the ACI. Aadhaar Consultancy and Infrastructure is a small business startup. We started after Sikkim earthquake 2012, after Sikkim earthquake in 2011, and with a sole aim of making structural and seismic retrofitting as a business line of business. Was a very hard decision. Convincing people to do retrofitting for earthquake safety in a country before us probably was not heard of. But we have been helped all throughout. So here I'm going to show you certain experiences of ACI. ACI has been doing a lot of work all around. As Dr. Ghosh said, we have been working with the buildings. At the same time, we have been working with the infrastructure. We have been working with the metros. We have been working with the bridges. We have been working anything that is built with concrete. To the extent that we are presently working on a heritage building again. ACI has been entrusted with a job on the heritage building in Qutub Institution in Qutub area, main Mehroli village, a listed heritage building. We have done seismic retrofitting of non-structural buildings. I mean, like non-concrete buildings, like mud buildings and things. We have done with the frame structure. We have done with the composite structure. We have done with the steel structures. Everything you can think about the concrete and the building industry, ACI has probably worked on it before. So please allow me to present ourselves. I just gave you about us very briefly. Now, this is what comes up to your mind when you are living in a high-rise building and an earthquake is to strike. This is an image from Nepal, 2015 earthquake. Most of the damage you can see in the building is non-structural. So first decision on an obvious front is whether the damage occurred during an earthquake is a structural damage or a non-structural damage. That's the first thing that needs to be decided. I'll just quickly run through these images. Dr. Ghosh has got a better pool of these images than me. So this is a structural damage, buckling of a concrete column, failure of a concrete column. Another failure, look at the reinforcement on the left-hand side. The reinforcement, the folded reinforcement, absolutely nothing in the stirrups at all. That is Gujarat, famous picture of story collapse. This is again Sikkim, non-structural damage, but to an extent that the plaster is as heavy as the concrete itself. Back to Nepal, shearing off of the beams. If you can see this part, shearing of the beams over here, damage into the non-structural parts, and so on. So yes, being based in Delhi, we have a majority of our works happening in or around Delhi, of the NCR region. And a lot of, though we have worked up till Bihar, we have worked in the hills, we have worked into the western part of India. but majority of the work is still in Delhi NCR. And this is one map which all of us are probably accustomed to, a microzonation plan of the soil for soil safety in Delhi. And you can see this right hand side purple area, the entire Trans Yamuna area, as absolutely unsafe part. Obviously, the reasons for poor performance of the RC frame buildings, and Mr. Amandeep must have taught you: inadequate design, substandard quality, long period effect of the concrete, soft story damage, and local soil conditions. I will actually not go into the theory. I'll rather take you to some interesting images. But before going into the experiences, let me show you how we also work. We also work the same way. We also work the same way. The reinforced concrete frame buildings needs a thorough visual inspection first. Structural condition survey through entities, study of the structural drawings, soil investigations, geotechnical studies, seismic analysis, and last is the designing of the rehabilitation scheme, which comes up for the deficiencies. Now, what are the deficiencies generally in a constructed building? Deficiencies of a building structure probably you can't see through with a naked eye. Obviously, you have to have some scientific tools about it, which goes beyond the premise of this particular training session, because at this training session you are more referring to the visual analysis, the visuals. So what is the deficiency? Probably let's leave that question at this moment, but at the same time, the deficiency of a structure manifests itself as a distress on the surface of the building. So any crack that appears on the building part, whether it is on a surface or column, beam, wall, anywhere, it has got a story to tell. So your RVS must focus on the rapid visual. Your RVS must focus onto the distress noted onto the columns. So in this particular image, if you're looking at the column image number 2, you're seeing a long linear crack on the surface of the column. The crack itself is narrower on the top, narrower on the bottom, and wider in the middle, which is a sign of corrosion, which is a sign with the problem of reinforcement corroding down and a reinforcement facing certain troubles. The image onto the left hand side, again similarly, the similar linear thing in the line of the reinforcement of the column, narrower on the top, narrower on the top, narrower on the bottom, narrower on the bottom, in the middle it's wide. It's a concrete which is being pushed inside out. So what happens when you open it up? When you open it up at the lower end, you get to see that the upper part concrete is absolutely fine, but the concrete is damaged at the lower end simply because the reinforcement is completely corroded. Any distress to the, needless to say, any distress to the reinforcement is big, makes the structure unsafe. What do? You immediately tie it up with additional reinforcement, find out the deficiencies, design the reinforcement required, and repack it and recast it all together, which is effectively called as strengthening by means of column jacketing. The column is jacketed with a new surface all around it. If I can say this, in a human being, a bone cracks. So a doctor, you go down to a doctor. What does a doctor do? Doctor says, I'll have to plaster it up. You can't move it. It will heal by on its own. The calciums and the other minerals within your body will heal that bone crack, and you should be fine. In case of a concrete, there is no natural process. So a plaster or a covering or a jacket needs to be applied onto the column for a permanent basis. And that is what a retrofitting design needs to be worked out. So if that is a jacket, additional steel has been added onto the column, then steel can be added to any building or any construction in concrete to make it more robust, more strengthened, make it more seismicity proof, or I'll say more susceptible to the damage of an earth during an would be caused to the building during an earthquake. So any structure can be strengthened to any scale by means of a jacketing. The picture you're showing, seeing is from a bridge on the Ara Chhapra. It's called as Ara Chhapra Bridge on the river Ganga. And this is where the columns have been strengthened and have been strengthened for additional load to be imposed by an earthquake. This is a finished product. So here you have a project, here you have a pillar. You can see the diameter of the column over here. And this is what it comes out after it is finished. Now, this strategy of jacketing can be applied anywhere and everywhere to strengthen your buildings for the seismic load. Most of the old buildings, which were designed with the old parameters, the national building codes prevalent only at that time, and now that the codes were massively upgraded after Gujarat earthquake, so that doesn't mean that the existing buildings were safe at that time for that particular codes are now safe. The code is a guideline. Your guideline, if the guideline has been upped, then the structure needs to be strengthened accordingly. So jacketing of any member, whether it's a column or a beam or even a slab, can be undertaken to strengthen it to reduce the seismic risk. Just as the column has been strengthened with additional steel and then jacketed with the concrete, same measures can be undertaken on a beam. You can enhance the size of a beam as well. So if a beam has been under design, or if a beam is found to be under design, probably the section can be enhanced by means of a concrete jacketing. All you need to do is add the appropriate reinforcement and box it up. That can be done to the whole of the grid together. The other way to do it is, if you don't want to do it with concrete jacketing, if you feel concrete jacketing in that particular location is slightly messy, then the way it can be done is to reduce load. Now the beams over here have been designed for certain loading, these beams, and the slab is found to be inappropriate for that load. So you can reduce the load by reducing the beam span, adding an additional element into it. At the same time, existing beams can be repacked from every side and the size is improved. Or these can be jacketed by means of a steel plate. The advantage with the steel plating work is you can limit it to the whatever zone you need to be. I mean, if the jacket needs to be done only to the shear zone, then a steel plate is a very effective means and mechanism to do that. Same as with the slabs, collapsing slabs. The soffit of the slab has collapsed because the reinforcement under it has corroded. And these corrosions obviously leads to the distress to the structure. Imagine an earthquake happening in a condition where probably your concentration of a building is this one. Look at this beam where the main reinforcement line is corroded and cracked. Look at this beam here. And at the same time, you have got a condition of a slab which has got no concrete cover beneath it. So what happens? The effective section area of the slab reduces drastically. That means if the effective section area reduces, that means that the load carrying capacity and these forces that it needs to take care of the members reduces. Solution: add another row of reinforcement beneath it and pack it up. Or steel plate it entirely. Section size improves. So you've seen a white beam, the size of the white beam, which is the existing one, and then you see the jacketed size of the beam. The size increases. Now, nowadays, there's another new material which is available, which is called as carbon fiber. Now, carbon fiber is a cloth which is as good as a steel plate. It's more ductile, it's more easy to handle, and it is some sort of a cloth which probably can be wrapped around the beams to be covered, closed, and finished. The same means of an external reinforcement. I mean, these are the means of mechanism where you probably can work upon your quality. In case your steel is found to be insufficient, then the steel, once the steel is sufficient, you can't add, I mean, you can't break this up. So you have to add external steel. External steel nowadays is available in form of a carbon laminates. Carbon, of course, as you understand, is the hardest material currently. And a lot of carbons and the fibers and all these things are now being used in even the aircraft industry. The cars are being made out of this, simply because these are the hardest material and very light. So these carbon strips are very useful. These carbon strips add to the ductility. They're used as an external reinforcement, and any cracks which you can see are being marked by these white lines all around can be taken care with the external pasting of this. Now, similarly here, now this is Delhi Metro. This is Delhi Metro. If you see the black part of these, the black part is the carbon fiber wrap, again a cloth which has been pasted onto the metro lines as well. Incidentally, Aadhaar Consultancy and Infrastructure is the only agency which is registered with Delhi Metro for the retrofitting. So if you see with the column on your far left hand side, that's the original size of the column. Now, after the fire incident under this metro line, the column number 2 was jacketed and converted from a circular shape to a squirrel shape. I mean, there was not much damage to the capital, so it has been left. But at the column number 3, if you see, even the capital has been jacketed. So these are the 3 progressions. And at the same time, the viaduct on the top, the segment of the viaduct, which is a U-girder in this case. Sorry, not U-girder, which is it's a viaduct only. So we have added additional reinforcement externally with the means of these carbon fibers. All the outside, the black part which you can see from the concrete, which is very differentiable. Coming back to the building inside, you see the capital on the image number 1, the capital, and then the beam attached to it, the second part, the capital of the column, and the beam attached. So all the 4 beams, all the sides. So image number 1, column number 1, column number 2, column number 3, jacketed on the top for ductility. This is a seismic retrofitting because the code says that the joints have to be more ductile in order to take seismic loading. In the image number 2, that's a close-up of one particular part, and you see how that carbon wrap has been covered under a plaster so that it doesn't look out of place. The way to do it, you don't need to add strength. Your structure stands as it is. So what you can effectively do is you do a weld mesh and do a graniting job over it. Graniting adds the concreting, adds to a surface layer on the top of it. But all it needs is a reinforcement. The reinforcement is very basic reinforcement, which can be taken care with the weld mesh over here. These are the methods that we have used in the past for the distress that we have noted. Now, I'll take you to another kind of an experience here. What if in a structure you go and you find out that it is not the distress which is hurting you, but the seismic safety is primarily required because these members itself are underprovided. So you add the members. This is one project where in an existing building, shear walls were added. Now the shear walls need additional reinforcement, and the foundation strengthening. The foundation comes from on a building with a micropiles. So you can see towards on the left hand side, micropiles have been dug inside a building, anchored to the bedrock beneath, and then the bedrock, once the micropile comes up, these have been covered with heavy foundation caps from where the shear walls begin. This is altogether a new prospect. now we have started using not piles but micro piles or ground anchors as a method of retrofitting. In case of a shear wall, the moment you are done with the foundation, first you have strengthened the foundation, then you have to strengthen the superstructure. Once the superstructure has been strengthened, you can add shear walls in between whatever brickwork, brick locations and things you are getting to. Or you can add an external steel structure altogether. On the image number 1 on the left hand side, you see these steel beams added to the balcony. And similar on the image number 2. This again is a ground anchor now. Ground anchors can help you. Ground anchors can help you strengthen anything, be it a shear wall, be it a counterfort wall, or any retention wall, or buildings, anything which has got to do with the soil stability. Even the foundations, as I explained in a building. So once you design your loading for the anchors, these ground anchors, you can install it simply by drilling inside into the behind the wall, into the soil behind, and anchoring it, inserting these reinforcements into it, and grouting it together. It is a very useful technology in the hill area. Anything and everything can be saved with it. Any building. This particular picture comes from a project in Dehradun. We've been working with the 3 or 4 school buildings, IMS, DIT, and other ones, where these technologies have been used. Very cheap, very effective, and easy to maintain. This is a higher end of ground anchors, where the soil anchors are pre-stressed. And once, obviously, that depends upon the calculations, the tonnage and the things. These ground anchors are then pulled into location. I mean, in the earlier ones, we only had one reinforcement rod inserted, which is this one coming out of the wall. That obviously has got a load limit. But when the load capacity required increases, you have to go into pre-stress anchors. But they act similarly. See it in the lower image. Now, this is the one which Dr. Ghosh was referring to. What happens when your installation system and the support system is absolutely fine? Your existing building has been strengthened, but even then the seismic loads being applied are not, it's still not good enough to take care of the seismic loads applied to the building. Then you go for existing exterior support systems. This is one project which we are now on way to do it nowadays at a modern school in Delhi, which effectively would be the only seismically sustainable building in Delhi at least, where we are installing these seismic brakes. Seismic brakes are basically friction dampers. And friction dampers work on the same principle that whenever there is a movement, there will be enough friction created within these dampers that the building and the ductile corners of the building will not move too much. We'll explain this in a detailed manner slightly lately. But before all this, what Dr. Ghosh explained in his RVS, what you need to document is what are the damages, what are the distresses, how you document. You have to differentiate whether the damage or a distress being shown in form of a crack or anything, is it structural or is it non-structural? If it is structural, then it needs to be treated as I've shown into the earlier slides. But if it is non-structural, if it is very minor, then there are means and mechanism to treat them differently. These are epoxy injections for those minor cracks on a beam. I mean, these are torsion cracks in a beam which are not very deep. These do not go beyond the line of the reinforcement in the beam, but these are still enough distresses to create worries which may open up during an earthquake. So you have to fill them up with a material which is sort of a glue or whatever. It ties up the concrete from inside. Once you have jacketed, you have to fill up the gap between the existing and the new concrete. Fill up with epoxies. Or if there is a cavity beneath, open up, make drill holes, and then you pack it up. Pack it up with cement. Remove the additional load, remove the structure, whatever is not required, or the damaged part, or the demolition, obviously going by the system the way it is. Now, This is seismic retrofitting of a non-engineered building, a completely different ballgame, where a non-structural building is this brickwork where there are no columns and no beams. So even over here, the principle of retrofitting remains the same. The principle remains that you probably will have to convert it into a box action. It needs to be tied together. A reinforcement and a column or a beam is not there, but a part of the brickwork itself can be converted into some sort of a RBC, which is called as reinforced brickwork. Now, brick that needs to be added with by means of jalis and things. This can again be designed as per the requirements. You can even convert. If you see the left hand side lower image, you can convert into a brick wall into a shear wall by adding reinforcement on the outer surface and then doing a shotcreting on a concrete surface. Or onto the left hand side upper image, you can convert a part of a brickwork itself into a beam. Very easily done. Or you convert a part of the brickwork into a column at the corner and attach it with the chicken mesh and all these things at the end. So effectively, the idea is if you get your diagnosis of a building right by means of a RVS, and your RVS is done, then any and every building can be converted, can be retrofitted, and can be strengthened for the seismic services. And this is exactly what ACI do. A short description about us. I have been the founder of the company, and my experience, obviously, as I said, has been a disaster management from the back. I've been worked for 13 years, and now it's been 9 years that I've been running this company after that. And we have done a lot of work, presentations, and this in this field, a lot of people around. And we have got huge number of satisfied clients, including Government of India enterprises, including multinational agencies, including corporates, institutions, and real estate groups. We have worked in Nepal, we have worked in Bihar, we have worked in UP, in Rai Bareli, Dehradun, Rohtak, Sonipat, you name it, and been there in the northern India. Thank you for a short presentation, for a very, very short meeting. I can take questions if you want me to.
Wow.
Very simple.
Thank you.
Okay.
Yes, Professor Ghosh, please share your comments on the very simple and nice presentation. I mean, I could understand all the different techniques you could speak about, the different sections of the building, how they can be retrofitted, what are the rehabilitation techniques, and different fibers, laminates, wraps you talk about, and how non-engineering buildings could also be retrofitted. So for me, it is a very educative presentation because I am a non-engineer person. So very nice. So I request Professor Ghosh to give his expert comments on this presentation and take up the question answers.
In fact, whatever is presented over here, that is, there is no need of any expert comments on the expert's presentation because he has presented very crisp manner, but very much rudiments of taking care of the buildings that which we think we take the pride that we design, we construct, and we rehabilitate, we follow the code, but seeing the deteriorating conditions of the building, just like that, we as a human being, maybe, of course, we take lots of pills and lots of capsules as we cross certain barriers in the life. But at the same time, building also is as a human body that which we neglect most of the time. But when it comes in terms of so many cancerous items are there, so many things are there which is being reconditioned, and also checking them that whether they are all right or not, like health checkup, even post-rehabilitation measures, which is, of course, their organization, they do that whatever repair that has been done and before and after, whether it is going to respond from the future effect or event in the long run, or with certain kind of warranty or guarantee that maybe 25 years, 30 years of things or guarantee is there or not on the building. So in that way, in fact, even though this is the retrofitting that most of the participants over here, they are expecting something like this, which you have presented, even though it is a rapid visual screening only, survey only, rapid visual screening before you, that was what I was presenting. But they have got the entire thing that what is to be done for reconditioning the building.
Yeah.
And with many case studies across the country. So that is really wonderful, fantastic. So Gauri Shankar Dubey, and then wonderful presentation on retrofitting. Okay, Gupta Sahab wants to make a comment. Let us see, because we are not seeing any query. I don't know what happened to our participants. They are more than 170, 75.
So just to begin with, I make a small comment, and I would request Mr. Nitin to just have an insight on that. But being into this field, I've been hearing about that whenever we go for retrofitting, the cost is a big concern. Sometimes it is so high that people says that it is better to go for reconstruction instead of retrofitting. So what is your, experience on this aspect?
No, this is absolutely a myth. Retrofitting of a structure for a new construction when compared to a cost of a new construction can't be more than 30 to 35%. If a building needs a retrofitting and a cost comes out to be more than 35%, or even I say 40%, we would tell you and recommend you go break it and construct it again. But that is never a case that I have seen, at least in past 9 years. Retrofitting is the most economical way. Yes, you are right. Haphazard retrofitting or adding elements that probably are not required to be done may add to the cost. But retrofitting after a correct diagnosis, a correct analysis would never cost you more than 30 to 35% of the new construction cost. That's for sure.
Okay, sir. Professor Engineer O.P. Gupta, VSM, Senior Advisor of the CIDC and the Acting Registrar of CIDC. I'm a former Chief Engineer. I have dealt with this retrofitting also in my area during my time, and my experience is that the retrofitting is the best solution, and whatever Mr. Nitin has given us, it is a very good talk, and I congratulate him. But the question is, when the retrofitting is designed and planned properly, then we have seen at the site the people are not trained to deal it. We have also seen sometime the people go for the retrofit when it is not required the retrofit. It is required to only renovate it for energy purpose or water conservancy or waste management. Or one thing we have seen a number of times, the people go for retrofit, whereas it requires neither the retrofit nor the renovate. It needs replacement. Replacement is rather cheap. We see sometimes, let us have a design and calculate cost effective, whatever the scheme is there, whether iterating, renovate or replacement. Then we see whether there is need or not. I am in Delhi. I have seen in my tenure that I was also dealing with the planning and designing, and I see it. And I will say, the training is most important. If the training is not there, then the people should be trained, then they should be used to, otherwise there is no benefit of that. With these remarks, I close it. Thank you.
Okay. Thank you, Professor Gupta. VSM.
I want to make
for the
ask
comments.
a question.
We see some.
I want to ask a question.
Yeah. Not audible. Sunilji,
Connectivity issues.
Okay.
Stuck.
In the meanwhile, let us see some of the chat box
My-
queries.
Building is
How to
4 years.
convenient general residence of residential building if needs
Uh,
retrofitting? What is your experience in
and
Delhi
the-
and India? Yeah, lots of experience.
Lots of it, sir. Lots of it.
It is
Yeah.
in all the
Yes, it is even a majority of the building, which I often tell that they are not retrofitable because they are not approachable. You need certain working space.
Yeah.
Majority of the building, they are not fit for
All that
retrofitting.
is
They are not fit for putting like
my question.
surgery.
So I think,
it is one kind
so
of surgery. It is
Mr.
not
Sunil,
possible because of
I
the
think wants
approaches.
to ask a question. He's trying to ask that. So we can
Okay.
hear him first. Yeah.
Yeah, yeah.
Okay, as I was saying, I live in an apartment which is 45 years old. Azad apartments, you might even know them in Delhi. And
Little
in
louder.
this 45 years, we have seen many earthquakes, and the building has not had a problem except because of the bending moments. In one of the buildings, some cracks on the ground and first floor. Now, the building being
yeah.
old, there's been a lot of seepage, due to which there is a lot of internal. We are trying to question is the steel. We are trying to replace the steel. How effective is going to be this methodology, and possibly, I mean, as a guesswork, how long will the building, life increase, if at all?
So you can design your retrofitting. I mean, obviously, a lot depends on the scheme of the rehabilitation and the retrofitting. If you're living in Delhi, and I obviously understand, we work a lot in these areas. We work a lot in Dwarka, Gurgaon, Faridabad, Eldiko, I mean, the Noida part. Even we have done an IP extension, and we have done some buildings in Janpath, on Janpath as well. So all these buildings obviously have got a space constraint, but then the scheme of the retrofitting, or if I have to use a word rehabilitation in your case, 45-year age, old age building would require certain amount of rehabilitation as well. So first you need to understand there is a difference between the two terms. First is retrofitting and other is rehabilitation. Rehabilitation is more about onto the surface repairs, the cracks appearing onto the plaster, or probably your systems or your services leaking and kind of things. Retrofitting is about your structure. The structure retrofitting scheme needs to identify the deficiencies, whether the steel provided 45 years ago was sufficient enough, or it needs to be added upon as per the present codal provisions. If you can go, then you probably will have to design if the addition of a steel is an economical process to do it, or you have to go by some other means of jacketing. There could be space constraints. You could go even for the steel plate jacketing. You could go for anything called as wraps around in case there is only a compressive strength deficiency, in case your steel is absolutely fine. So a lot of this question gets answered if you get an effective repair, rehabilitation, and retrofitting scheme done. So you've got three aspects to your problem. Repairs.
Thank you. Thank you very much, sir. Thank you very much, because luckily this is the line on which we are proceeding.
This exactly should be
the steel and
so steel jacketing is
the steel and
jacketing steel.
No, I mean replacement of in certain areas and.
Okay, there are many questions in the chat box, but at the same time, our next presenter is also there. So, Mr. Nitin, may I ask you if you are available after this presentation also, so that we can take up all the questions?
Sure, you can check with me. I mean, I might have to leave, but you can still email me the questions. I can answer them. It would be my pleasure to answer.
Okay, we really want to take these questions, but since the next presenter is also waiting, so we have to.
We'll forward them.
Should I share my email ID with you?
Definitely, yes.
We have it. So
you can share it in chat box also.
That's exactly.
Yeah.
You can directly.
You can share in chat box, and If you can
Or
spend
you
some
can write
time in
to-
the chat box, you can
write
directly
to
answer
IDC
also
to
right now,
forward it.
if you have some time, or later on, otherwise by email.
So
they
I
can respond.
incidentally, I have sent you a direct message, which probably you can broadcast or something.
Okay, that's okay. You have sent it to me. Okay.
I've sent you a direct message. If you can just broadcast it to the editor.
Okay.
Okay,
Okay. Thank you, sir.
thank you very much for your.
Thank you so much.
Thank you, sir. Thank you. Thank you. Thanks a lot.
Okay, so we may move to the next presentation of the day. That is, I welcome Mr. Manish Kumar Bharti, CEO Crotex Construction Solutions, for making a presentation on online certification based on RVS course. And Mr. Manish, may I request you to kindly just switch on your camera, so it will help us to locate you. And
Yeah. I was trying to unmute, but
yeah, Mr. Bharti.
Host may please unmute him.
Okay.
it is not taking place. What happened?
Yeah, he's not there.
It is one Manish Kumar is there, but we are not able to. I am trying to asking him unmute, but it is not happening.
I
Okay.
just spoke to the host.
Sir, can you call him just to know?
Yeah.
Yeah.
Yeah, I
I
just
think he
called
might
the
be in the
host.
meeting in Chennai. Is this?
He's looking for the speaker.
He might be busy. Let me send a message.
Okay. So just in case Mr. Nitin is also there, then we can take up the questions in the meantime.
Okay. We can take few questions till he joined, because he is not reachable by phone.
Okay.
Now we can take few more clarification. Okay.
So there are questions on carbon plating retrofitting. Carbon plating retrofitting, sorry.
FRP, fiber reinforced or carbon. Huh?
Yes. Kindly let us know about carbon plating retrofitting.
It has not. Carbon plating retrofitting.
Yeah.
Okay. In fact, some of the lamination that has been done even in metro, or even many beams and columns have been shown. It is all, there are number of such materials available in the market, fiber reinforced plastics. So these are very plenty of them are available, but their specific use as well as the purpose are very much well defined under certain principles that to be followed. In fact, while visiting one of the school building there, model school like in Delhi, where retrofitting has been done few years back, But currently what is going on, there we saw that they have done the retrofitting of the beam in classroom, disregarding the tensile phase of the beam. Generally, we know support portion and the middle portion, unsupported portion. Unsupported portion, bottom of the beam is to be strengthened by providing at the bottom phase where tension is more, where plates or FRP to be used. Whereas we saw that in that building, I have the photograph, that they have put through and through from one support to another support continuously without any break. So which is not the right way. So it is not that there are number of such materials available in the market, but qualified, experienced and proper calculation and positioning, then correctness, fitting them in an appropriate manner and followed by testing them, evaluating their expected performance or expected behavior for a certain period, at least for next 20 years, whether it is going to take up or not, or whatever amount, as Nitin has mentioned, that about 30%, 35%, if it is less than that, whether it is being justified or not. So it is a very, very big aspect to be looked into before taking up retrofitting. And as you know, retrofitting costs many things, and there are many non-structural factors are also there. People will allow, even if it is allowed, you may remember that one of the building photo that I have shown for the last 10 years, that it was lying like that, tilted positions in Shimla, Hill City there, it is lying like that only. So there are many non-structural issues are there, rather than for civil engineers expertise with having retrofitting to take care of that kind of building which was tilted for more than 10 years. Non-structural, I would say it is that who will take care, or four floors are there, who will take care of the rehabilitation? Are they going to be put up before dismantling it, or decision for correcting it, like Leaning Tower of Pisa was straightened to a certain degree more than 20 years back, whether such kind of decision will be taken or whether the space is available or not. So many such ifs and buts are there before choosing or taking care of the material that will be used. So there are a lot of things. There are specific sessions are there, which I would recommend that you please go through those kind of specific one rather than it is general. We cannot answer just only by speaking.
Yes.
Is not going to help.
Yes, sir. Yes.
Okay. So would you like to know?
There are some more questions, sir, if you would like to see,
yeah.
and pick and
Would
choose.
like to know the cost vis-a-vis life of this we have said that these are all many things unexplored. Gauri Shankar Dubey Sahab ne likha hai, vis-a-vis life of build or structure enhanced. In fact, you see, when we are in this world or in this situation, when we are making new construction also, none of us can assure, because there are so many, again, I am saying non-structural factors are there, whether concrete quality is all right, design is made, okay, but whether 135 degrees made or not, whether joint and connections are made all right or not, whether proper quality control has been made or not, proper right kind of dimensions are there or not, geometry is there or not. There are many things are to be checked in the field. When for the new construction also, in many cases we are struggling to bring sufficiency in the quality control during construction. There is a lacuna in training and of the mason that who are involved there. So there are many other factors like the foundation that we have been discussing. That foundation part also, that it is simply a bearing capacity, adaptive bearing capacity based on the formula that given in the book, or the soil profile that known, and whether it is liquefaction prone, whether it is going to have a more settlement, or whether that what is the earthquake signatures there, whether attenuation will be there or not. So whatever new constructions that we are making even every day, everywhere, in all facets of things. And we are not in a position, or rather we do not have much of this, which you say life of the building or structure, even after retrofitting. So it is still a lot of gray area is there, which simply by discussion over here, probably it will not, I will not be able to give you a justifiable answer or just for giving an answer. So it is a gray area that which is to be looked into our profession, and which is far way to proceed with. How to convenient general resident, this we have discussed already, that many of them are not retrofitable, and many such logistics problems are there, finance, and then removal, and then nearby areas, that how it is to be done. So those are all area that we cannot address. Can a building could be effectively converted to sustainable green as per national international standard? What would be a thumb rule cost in approximation? The cost part, you know, it is a very highly reclusive items. Same aspect of work if you do in one part of the city to another part of the same city, or one colony to another colony, or one kind of same kind of material from one shop to another shop, whether it is a local shop or it is a retail shop. So it all cost involves, and also that labor cost that involved. It is not only labor, the kind of expertise that we have to bring in. Some of the installations that Nitinji has shown about the structural control, whether it is dampers or friction, or even tuned mass damper, or active mass control, passive mass control. There are many such control devices available, including base isolator and other things. So those, particularly if we take care of those items that which are available in most of the other countries, and many of them we have started producing in our country, but not much awareness is there towards utilizing those devices for the seismic control of the building. And most of the cases, in order to make our building capable of controlling themselves, first in case of earthquake, or controlling along with fitting of those control devices, it is a complete understanding of the building and its location, the type and the age and strength and their capability. So there are lots of things to be looked into. In fact, that becomes cost-wise, of course, every aspect to be looked into requires a cost, which is same as every kind of testing or pathological or scanning or CT scan, PET scan, whatever kind of test that we do for human bodies in our health science, or in a medical science, or in medical profession. Similar kind of say cost categories are involved in order to take up. Now, thumb rule is, of course, the affordability as well as accessibility and also expertise, which are in great demand in the country. So that part, in fact, is very much important. So, is retrofitting possible all tall structure? In fact, here is a very nice question. For tall structure, in fact, we have not yet thought of anything to go for the tall structure. And in the previous presentation, Nitinji has shown you some of the signatures of the damages, cracks, that and what are the cracks, whether the hair cracks or larger cracks, what is the due reason behind that. So once those reasonings are clear, then whether in all kind of tall structure also, tall structure, there are certain things are there conventional way, some of them that he has shown in examples, some are even some are being done in a more sophisticated way these days. Like in case of tall building, if earthquake is the main concern, then we have to look at that in order to we can repair the building, but it may not be strengthening of the building for tall buildings, say 10-story, 20-story plus. So in that case, retrofitting in a real sense, which is strengthening of the building for the entire building. First thing is that if it is an existing building where people are living over there, so it is not possible for a 20-story building and evacuating them, putting them in a hotel or some other building and something, which is a gigantic task to be taken into. But while nothing like many of the hospital buildings or school buildings are being retrofitted in the country, that without disturbing their regular function. Now you think of hospital, 24/7 it works, but not all hospital that we do not have that kind of sophisticated know-how, technology, as well as expertise that the hospitals, that many of the hospitals that which are operational and retrofitting can go on without disturbing their day-to-day affair. It is many cases they are not feasible, even though it is possible. But while possibility, taking the feasibility and possibility together, then we have to see that what are the strengthening measures or isolation measures to be taken, which like in case of a tall building or even a hospital building, many examples are there abroad that we can put some of the isolation devices by cutting the column at appropriate places. There are so while cutting the column and arranging those machinery and those things will not disturb the functionality of the building as a whole. Maybe some portion, some aspect may be looked into while cutting the column and placing them systematically, putting all the struts and supporting system and putting the base isolation devices. And while looking at that, putting the devices is not enough. We have to look at that only that if base is being isolated theoretically and devices is also available in the country, of course, not yet much manufactured, because testing and evaluation are also required. So we can buy them, and there are many such projects have been taken up and completed by base isolation. But the problem is that one aspect will be coming because it is to be bought from abroad. Another thing is their feasibility again with the kind of arrangement to be made at the site. So simply, I have number of examples of that, but I think it will be, this is not the right time to put in those slides to show you how they can be done or have been done in the country in some of the particular cases. So for tall buildings, instead of going for say 20-story building, each and every floor, that retrofitting measures to be done, and which is not feasible, as I said, but at the same time, at the bottom or at the steel floor, if a column is in between the column, its isolation devices are inserted, then no vibration from the ground will proceed towards the upper floor. So that is the theoretical way. Practical way also, many important buildings have been made free from experiencing vibration due to earthquake expected in future. So those kind of things can make the tall building more affordable and feasible without much taking care of the logistics to be involved while it is while people are living over there. So there are a lot of examples, case to case. I think when it will come, then we'll see. Oh, what about the retrofitting of our existing parliament building? My camera, someone is going to control my camera. Okay. Okay, I have given the approval. Yeah, parliament building, retrofitting our existing parliament building. As far as I know, about several years back, there are some rapid visual screening being done and things are noted and report have been submitted. That much, but it is very much retrofitable, provided there are, again, I say that in a word, the logistics are made available. And for that, expertise are very much available in the country because it is a parliament building and some of the measures already shown and some of the steps being taken, like in the previous presentation by Nitinji. It needs an expert consultation as well as site visit. When it will be made available, then of course it can be retrofitted to an acceptable level. But money is not the main thing. Main thing is making it as a heritage, and it is a famed building. Of course, new Parliament building is going to come up. Then it will be becoming an heritage building, which will be kept as it is there. In that case, of course, some kind of repair and retrofitting measures would obviously require the attention of the government for these Parliament buildings of the country. Okay, I think Manish Kumar ji might be busy because he arrived from Calcutta to Chennai. So let us take it forward now with any further questions, or if you want, I can continue with the formats that new format that I want to
Yes,
take
sir.
care.
I think,
Huh?
yes, yes.
Shall I?
I think that would be better. Yes, sir.
So 10-15 minutes and
10,
then
15 minutes. Yes,
yeah.
yes.
Okay. So I go back to my presentation where I left. Okay. Yeah. Okay. There are these just only there are many ways that our city facilities, street map view, like you see, walk through, these are being done. 100+ cities got there, all the sites and everything you see. These are the photographs done through a LiDAR. You may see some of this kind of YouTube video also, that how walkthrough is being done with the dimension, and one can go through with a handheld camera, LiDAR camera, to each and every, like the way that you can walk through this virtually. You can take a tour. Once this survey is being done, then this can be made available on our mobile or on our website or on the web portal, that one can go through these, and then you can see this wall, that wall, along with the distance, along with the measurements, because which is a vital thing, that so you can go and you can check each and everything. You can, because one survey is being done and that can be uploaded and make it available as a walkthrough, which you are familiar with. Or even on the street, it can show the directions, and then it can take measurements, and then you can have that where is the crack, because they can identify even a millimeter or sub-millimeter level of dimension on the actual building or roads, or even anything that which is visible. I say that even kilometer away, it can make the things visible, and visible along with the dimension. And then accuracy or level of scale that you need, that depends on what kind of requirement is there for taking up. Like while checking a aerial view of a road or street, and keeping such kind of CCTV camera on the road, and then also now intelligent camera are available. Like if in such situation some accidents or crash is there, so one can have a right information over here, not after the crash, but with intelligent camera. Before that, we take decisions that we can take this kind of camera can identify and check that before event happen. Also some kind of siren or some kind of say warning can be given over here, displayed over here, or to the, now we have got so much of sophistications in our technology and IoT devices. At least we know that while going through the road, that these days we can make freely available web camera type of application loaded to our Google Map, and then it gives us that, okay, 500 meters away there is a camera, so speed slow, whatever is that. So our travel is being guided constantly through our Google Map. So such kind of, for the buildings also, there are certain examples are there, but and certain studies for 100+ cities have been taken up for street view. You can type the, say here I am in Rohini, here sector 29. If you type it there, whatever the Bhavana road is here, you simply type this, it will take you there itself, and the road will be visible there, or with the available camera over there, which can be connected to the mobile, and you can see live which is the car and other things are going on. So that is the capacity as well as potential of making these urban development applications, or taking this advantage of such applications of the camera into our building survey, that which we are moving up with this program onward. So before going to the format, I would like to take you to some of the regulations that in our cities, that a site map has to be shown there on the site during construction. This is as per rule, as per structural, but there is no structural drawing still being sanctioned in many of the municipalities. And so this site map will be there, but in majority of the cases, as long as the authorities are careful, or not careful, rather authorities are active, then they put up and then they take it up, because this become a public show. Like I have taken it, one of the construction using my camera. There may be some objection, but this has to be displayed on the construction site in many, which is to be followed as per municipality, say guideline, or say building the development rules. So while such kind of constructions are there, of course, this I often show, you see that the kind of constructions and how we are going to explain their performance, which in fact I have mentioned in the first day. And if a building is having a column over here and it is over here, it is again I'm trying to look at an as-built drawing in the same construction site. You see that whichever is being highlighted, whether these are, because structural drawing is not passed and nobody looks at, everybody looks at the plan, which is a sorry state of affairs in the building construction, and see the aspect ratio of this column. It is 4 times the width, which is not permitted in case of earthquake resistant building construction, even though putting that 25 mm rod reinforcement over here may satisfy to our StatPro or software that which are say means whatever is the structural analysis or design, they may satisfy the design, but this will not satisfy the performance of the building in case of earthquake. So in that case, in fact, for a 4-story building in seismic 4 zone area, since such kind of shape is being taken, so software takes care of that. If shape is not regular rectangular with aspect ratio less than 1.5, then you have to provide extra steel. So what software is giving, in order to take care of such problems, then it is providing steel requirement here extremely high, extremely high. And on the other hand, when such kind of things coming from the basement and such a band is there, software doesn't take care of, and it is not possible to take care of their impact like this. So there are many defects that you will see, and see the lapping that which is being done, or 90-degree and other things. So what I would say that if we are going to say that concrete quality, it should not be less than M25, then in that case, how this kind of hand mixing can allow in the same site, which I am showing the drawing. I have shown the site drawing there, how they are going to ensure that uniformity in the concrete in the same floor, same column, same in the beam will be ensured, which software has taken into the consideration as a, say, M25. It is beyond, imagination. And in the same site, you see private construction, which is closed by all the 3 sites. And then when column is being made, you see it is at one site with the eccentric footing. Software doesn't take, or bearing capacity also doesn't take care of all these things. So we go for over design, safety, and all those things. and that cost. So finally, coming to this, the format, this just another thing that which we have revised in a simple manner, which can be taught to anyone. Anyone can understand that questionnaire for say RCC building or brick building or even steel building or prefabricated building. We can change some of these, but it is more generalized here. First thing is identify the building. In fact, in the next lineup of our training program to those AICT students and new or graduating engineers and all, what we are going to do to modify this format and also bring it to all of you that only incorporating these things in the mobile app along with the details that we have discussed in the just last in my previous presentation, that we have to make it more simpler for the beginners to start with in the rapid visual screening survey. So first thing is identify these things, and also it is said that take representative photo and measurements, draw sketches, a location of the staircases, drains, etc., showing good and bad aspects from the viewpoint of earthquake safety and vulnerability. So this is only combined earthquake, but later on, starting with the earthquake, we will add more dimension, like it is mentioned about the fire and other things. But here about the fire, we have added another question. There are 25 questions. There are 4 options are there: yes, no, not applicable, unable to comment. So if I take this thing quickly, that each question, if they are having the answer yes, it means some problem is there, some issue is there which is to be looked into for the next level of RVS. So does the building have an open story with just column and no unreinforced masonry, infill walls, either at the ground level or at any intermediate level? Please mind the question very carefully. It is about the steel floor and buildings, some of which that I have shown that even in Bhuj earthquake, or even in Nepal earthquake, or even in Mexico, many places that many such building has failed during earthquake due to the steel level because the stiffness difference. So if it is yes, yes. If it is not applicable, not applicable, unable to comment, but at least when we visually see the things, we will be able to identify whether it is having infill walls, either at the ground level or at the intermediate level. There are some typical failure has taken place, which I'll show. Just I'm going through the questions now. Does the building have floating columns or floating structural wall discontinued in the lower levels? So there are many buildings that it comes with say in an area say 10 meter by 15 meter, then which is within the boundary, inside the boundary, but later on they can go on after one floor, they can extend it with a cantilever, say maybe 3 feet or 1 meter or something on all sides or in 2 sides. So it becomes that whatever walls that they are making on the cantilever, they are going to be floating wall. Those are all dangerous, even though software will take care of their stability by looking at that where bending moment and shear force and reinforcement have to be provided extra. But in case of earthquake, they become vulnerable, even though software justify with the kind of formula that it is given. But as per thumb rule given, as well as experience that which is written in the IS 1893, such kind of buildings in the earthquake prone area, they are vulnerable, and for which only simply justifying or adding more steel may not be always justified. So does the are columns having transverse reinforcement 90? So this you have seen, I have shown before you, whether it is 90 degree or it is 135 degree. Does the building have slender columns less than 30 centimeter, which on the first day itself, Dr. Hemant Vinayak have shown you by putting a photograph just showing that how much is this one. So by saying that whether it is 30 centimeter or low, you can check this. This is less than 30 centimeter, which we have to develop certain kind of measurement by say this much, how much. or this much, how much, or if we make this, or one step, how much. So there are a lot of things we are now very fast forgetting about the field techniques of or field. When we go to the field, then we identify brick by brick with the dimensions and understand that how much is this much or how much is this much. So these are the things to be is to be learned while visiting the site in a as practicable manner as possible. So there are like 15 questions are there. Each are very, very easy to understand. Are infill masonry walls made with half brick walls or brick on edge walls? So this we can easily identify. So is the lateral load resisting system, moment frame, structural wall, frame wall, braced frame system absent along any of the plan directions? Are adjoining buildings or adjoining parts of the same building separated less than 2% of the height of the building? These I'll show some of the examples. In fact, all these questions are shown by some of the examples. There are 25 questions which are as simple as that. We have been deliberating these things that to aware that anyone class 12 pass or even diploma engineer to know about these things and record them, at least make a quick survey of the buildings that we are visiting. So all these things will be made into a practice package for making the country at least know about the location of the building, their status based on these 25 simple questions. And also, do the building have the fire safety devices as per, of course, NBC 2016, which is revised in place? So only this one question is being added over here. Majority of them, we have to go in a finer detail of taking care of the fire safety device, and in which case that fire safety officers or even fire safety services, that before giving fire safety certificate, that there are certain criteria which is recognized and recommended in National Building Code 2016, as well as it was there in 2005. So based on that, then we have to make a sub-file, a subroutine, or one kind of another say area that fire safety devices to be looked into. Similarly, electrical safety or electrical installations, those are to be added into the details while making the software, and those are to be made available in the portal, so that when actual site visit will be made, and these will be taught and this will be exercised, and then survey data can be uploaded, and then it can be analyzed by the experts, even doing online. In fact, today the first lecture was arranged in order to understand this thing by Manish Kumar Bharti, but unfortunately he could not join because of the meeting engagement. So we will see that while actual another further such say program will be taken up, then we will bring them together to go into more details in this area. Even survey is only 2 pages over here. Site-specific concerns and other comments, maintenance concern, general environmental control, housekeeping, fire and electrical hazard prevention. Of course, here we have to make some kind of fire. Then we say that go to the fire one, electrical, go to the fire one, where we'll decorate with all those queries that which will be looked after by the surveyor. And then name and designation of the field or inspector. There will be level or hierarchy of surveyor that who will check, and then inspector or engineer, whoever, and name and designation the evaluator who is going to evaluate. And not only that, based on this, there will be some kind of certification or some kind of report will come based on the criteria that which are available for the earthquake safety. In fact, Manish Kumarji has made many such certifications of the building. We'll see that he can present it. So the question 1, then we deal with just the first question. You see that it is having here, so there should be a mark like yes. This is having steel floor at the at the ground floor, which you have to note down here itself. open story or something like this. So while practical training will go on, then we take this format side by side, and then we look at, walk through, and then note down these things. Like here, there are the infill walls made with half brick or walls or brick on edge walls. You see these buildings, that how they have been made. It is very difficult to find out that where it is not. You see that this is here, it is something, here it is something, and here it is something. So it is so difficult. Only framing this question and going to this particular building, neglecting this one. This is in a hilly area, or this portion you see in the intermediate wall, question number 1, intermediate 1. And here also in any part in the intermediate, and then these are the slope. So this building shape, you can see how it is there. What is this? What is this? So every part and every dot, whatever you can, whether it is here, whether it is there, whether it is there. I have shown you one building like Lalita Park building. After that, when we survey, we have surveyed 10,000. One of the decorated building that we have shown that with arrows that what are the wrong part. So that I have shown as a cover page of the report submitted in 2011 November. So here also, here you can put story, you can make that whatever earthquake learning language or expertise that we know, we can write a big story on what has been not followed, or what is not, what is not convenient to, or what is not conformable to the earthquake safety standards or earthquake safety requirement. Other than that, you see that whether safety certificate is available or not, like just only one question that which is over there, fire safety devices as per NBC 2016 is there or not? Do you think that we can address the question potentially and functionally in all possible knowledge and know-how that we inculcate in our profession to address that question number 25 in such cases? That do you think that it is something like that possible? It is not at all possible. So there are buildings and that buildings that we have brought up and we are making it, they have become cancerous organ, and but still we are living until that D-Day comes here. In the case of structural safety, fire safety, or electrical safety, or whatever that is being indicated. But as a beginning, that we must check the current condition so that at least we have some kind of available resources and report, or at least we know that which are the vulnerable one. If some kind of warning is given there, or some kind of, these days IoT devices are being used across the globe, and which is getting along with AI and intelligent camera, we can check these days without much cost each and every parts of this building by camera or by those devices, along with air quality, fire safety devices and their temperatures and everything. Hundreds of such devices we can keep in our surveillance system. Then we can 24/7 we can see that where things may go wrong or going wrong, or what is the current status. That kind of things we can do more easily than correcting all those misconfigured items as per the questions that which is being shown over here. So here you can see the infill walls and other things which you can see, edge wall, and see that question number, okay. Are adjoining buildings or adjoining parts of the building separated by less than 2%? Where is that? If height of the building, say 4-story buildings, 5-story building, 3 meter average, so 15 meter, 2% of that becomes 15%, 15 meter into 2%. How much it becomes? 30 centimeter. So if 15-meter height, 30 centimeter, because it needs a free, while building will sway due to earthquake, then it needs that some space to shake or to move on its own so that it doesn't hit adjacent buildings. So do you see that in this kind of building in a hilly area, that kind of space is there? It is not there. So in that case, what will happen? Building may be stable due to earthquake, but it will make other building, you see floor height is, one is here, another is there. So this is a very strong part. If this hits here, we have many such failed buildings. Even in Sikkim earthquake that happened in 2011, 18 September, we have many buildings saw that develop crack or failed due to the hitting of this at this middle level. So there are many interesting live videos are also there on the, we call it pounding effect on the building. You see that there is no gap. These are the buildings in Delhi, in East Delhi, while we got this survey. So what kind of rapid visual survey that we are going to justify doing such kind of things? It is just not possible. That is why I was telling in the previous discussion that many of the buildings are not just retrofittable, not even unthinkable way of taking up any kind of retrofitting or reconditioning measures. They are not suitable. Only thing is that these days, number of materials and know-how are made available, at least to make one floor of this building, or even as a 3-bedroom house, one of the room may be made which is easily accessible from all the rooms that in an apartment or in a multi-story building, that which can be not retrofitted, but that can be strengthened by putting some kind of, some kind of very hard steel cases there. At least if it is, at least it will act as a black box in case of aeroplane crash or other things. So that kind of things are also taken up, and moreover, not justifying that this is retrofitable, but at the ground level we can go for isolating the vibration, not reaching to the building. Otherwise, if slight vibration is there, they are going to break. See the condition of this. So let us not make story after story on seeing such building. A photograph description through the rapid visual survey is enough to tell the fate of such building in case of earthquake of intensity, say 7 or above. So anyway, I think I have taken time, but this is an unending survey. It is already 5 o'clock, and there are some failure that you see at the middle that it is broken in Japan. This is in Japan, or this is a 5th story level that is intermediate. Question number 1 that I am addressing. So such kind of failure in Kobe earthquake also it has happened. And if steel floor are not taken into account, this will be the fate of the building. This I often show this thing that how our car parked inside, that we're going to see the fate of such kind of building if steel floors are there. So then how to correct the steel floor? But for that, I think I have spent a lot of time and convincing people to go for minimal way of retrofitting of the steel floor by flattening or by at least jacketing, or these days that we can isolate the entire building by cutting the column and placing with some kind of devices that we can isolate the foundation vibration, not reaching to the upper floor. Anyway, let me end over here. There are many things are there, each of the cases. Okay. Just this is the last slide that I wanted to show, that in those steel floor, the red colored the portion can be made at a simple full brick wall throughout this without disturbing the parking facility over here. This is the simplest measures can be taken, which is feasible and economically acceptable, rather than going for insurance, disaster insurance with so many companies that are available in the country. So let us not get swayed by ensuring our safety, by ensuring it to some of the company A, B, C, D. Rather, we spend just fraction of that in taking such kind of measures for the tall buildings. Thank you.
Yeah, thank you so much, sir, for a very elaborated one and very important one. I think now the time has come that we should close the session. So should I present the concluding remarks? And I don't think so. There is
Many slides were not
Yeah.
shown.
do.
Something is it? Slides were not shown?
Mm. Okay, she's talking about the slides which you skipped to show actually.
Oh, okay.
Yeah.
Because we'll take up later on. Please be with us. Your registrations are already there with CIDC and in our NIDM. We'll take more specific face-to-face program after Omicron is surpassing
Yes.
its virulence.
We will have more occasions to go through with these
Yeah,
slides which
yeah.
are being skipped actually. So the 3 days program, I should say, that have been throughout a learning experience, and we had technical presentations for the last 3 days. Several learnings regarding different topics have arrived from the case study of the 10,000 buildings in Delhi, mapping of structure vulnerabilities in built-up facilities, non-structural criteria in vulnerability mapping of buildings, deficiencies and caudal provisions, and performance objectives of buildings during earthquake, retrofitting of buildings, and also discussion on RVS format. So there is no denial that RVS is an important tool which can actually decide that what would be the future of a particular building or an infrastructure. Retrofitting could be one of the important tools for strengthening of the structure of the buildings. At the same time, non-structural elements are also important to ensure that even though the buildings do not collapse, a lot of damage can happen due to non-structural elements of the building. So it is an important tool which can be easily adopted by the building users or owners. We have learned about the RVS format and the changes which are required to be done for the revision of the format. Also, how we can make the use of technology through GPS and using camera, Google Map for application, to make the application more interactive and accurate. With these concluding remarks, I would like to thank each and every panelist for sparing their precious time for making these 3 days programs a great success. I thank each and every participant for showing up in such a large number and shared the zeal of learning. You made each and every session so important by sharing your feedback, your live comments, and raising questions. Please, I would request, please share your feedback on an NIDM website as well. Those who have attended 80% of the training program and shared their feedback, certificates would be received, would be shared to those participants from NIDM and CIDC. And these certificates would be available at NIDM website only. You can download those certificates by logging in an NIDM site. And this process actually takes a week's time. So please don't think that you give the feedback and you will expect the certificate. That doesn't happen. We will take the information from the collaborating agency about the time we will judge your participation. Based on that, we will issue the certificate. Last but not the least, we would like to thank the CIDC and ISS team for collaborating with us for such an important topic. And I wish that we could have some more such kind of important partnerships and collaborative initiatives in future as well. So thank you, everyone. With these words, I would like to close the 3 days training program. I think, sir, would you like to say something? Do you want to add something?
I think I have said enough. Huh?
Yes, sir. And from CIDC, if anybody is there who want to speak from ISS or CIDC.
On behalf of CIDC.
Yeah, Sunil.
On behalf of CIDC, I want to thank NIDM for their excellent support and their guidance in many things. Thank you very much, especially Dr. Ghosh.
Thank you.
Garimaji, you carried the show. Thank you.
Adesh, Kumari, and also Anand for an excellent arrangement of this platform. So much. Huh? You have been passionate
Thank you,
enough
sir.
to have this program
Thank you, sir. Thank you, sir.
and driving us.
Thank you, sir.
Okay, thank you. I
Thank you,
think
sir.
Vishwajit Kumar Ray wants to say something. Just quickly, few minutes.
No, I'm thanks for all.
Okay, thank you so much, sir. So I think now we should close the session, sir. We have already
Okay,
crossed the
okay.
timeline and it's more than 5 now. Thank you so much,
Okay.
each and everyone.
Thank you.
Okay,
thank
thank
Yes, CIDC may like to